All right, this is Unit 2, Lesson 6, the quadratic formula. So our lesson essential question is, how can you use the quadratic formula to solve quadratic equations or to predict the nature of their solutions? At the end of this lesson, you will be able to solve quadratic equations using the quadratic formula. All right, what values of x solve the equation? 3x squared minus 4x minus 9 equals 0. So the quadratic formula, x equals negative b plus or minus the square root b squared minus 4ac all over 2a, provides the solutions of the quadratic equation ax squared plus bx plus c equals 0 for a not equal to 0. So I write the quadratic formula. I substitute 3 for a, negative 4 for b, and negative 9 for c. And then I simplify. I rewrite the radical term with a perfect square factor. So our square root of 124 equals square root of 4 times square root of 31. And then I simplify. So the solutions are x equals 2 plus square root of 31 over 3, and x equals 2 minus square root of 31 over 3. Okay. There is a little song that you can sing. There are several songs. The one that I learned was negative b plus or minus the square root b squared minus 4ac all over 2a. So I'll try to find a couple of those on YouTube for you to be able to watch and or listen to. Quadratic formula is definitely one of those things that you should memorize. Not many things in math really necessarily need memorization. The quadratic formula is something that you will use to solve most quadratics. If you can't just automatically factor them, you can use the completing the square method, which we learned about last lesson, but only if there's a 1 in front of this x squared. Okay. Or you have a easy way to factor out that 3. So I could actually go through and do this where I was actually completing the squares, subtract, add the 9 to both sides, and then factor out this 3, but that's going to deal with fractions and things like that. So it's a lot easier just to use the quadratic formula. All right, how can you use the quadratic formula to solve x squared minus 9x plus 27 equals 0? So again, I write the quadratic formula, negative b plus or minus the square root b squared minus 4ac all over 2a. I substitute 1 for a, negative 9 for b, and 27 for c, and then I simplify. Okay. When I simplify, remembering that square root of negative 1 is I, so I get 9 plus or minus 3i square root of 3 over 2. So my solutions are x equals 9 plus 3i over square root of 3 over 2, and 9 minus 3i square root of 3 over 2. All right, so let's try it out. Solve using the quadratic formula. 2x squared plus 6x plus 3 equals 0. All right, so these are the first two examples. So the first example is 2x squared plus 6x plus 3. And we want to solve these using the quadratic formula. So the quadratic formula, again, is negative b plus or minus the square root b squared minus 4ac all over 2a. Okay, so what I'm going to do first is identify my a value, my b value, and my c value. So my a values I'm going to do in blue. So my a value is 2. My b values, my b value is 6. And then my c value is 3. Okay, so a equals 2, b equals 6, c equals 3. All right, so when I'm doing this, I'm going to just copy and substitute in my values for A, B, and C. So I have negative B, which is negative 6, plus or minus the square root of 6 squared minus 4 times A times C, which is 3. That's all over 2A. Okay, so when I substitute everything in, I get negative 6 plus or minus the square root of 6 squared minus 4 times 2 times 3, and I'm dividing it by 2 times 2. So I'm going to go ahead and simplify. Negative 6 plus or minus 6 squared is 36. 4 times 2 is 8 times 3 is 24. Okay. 2 times 2 is 4. Okay. So from there, this gives me negative 6 plus or minus square root of 12 over 4. Now I need to simplify the square root of 12. Okay, so I need to simplify the square root of 12. So the square root of 12, 12 I can break down into 3 times 4. 4 is a perfect square. Okay, so I'm going to use that. So I get negative 6 plus or minus the square root of 4 times 3 over 4, which is negative 6 plus or minus 2 square root of 3 over 4. Square root of 4 is 2, so that 2 can come out. Okay, now what I want to do is I want to simplify as much as possible. 6, 2, and 4 are all even numbers, which means that I can actually simplify this by 2. So I divide 6 by 2, which gives me negative 3. 2 by 2, which is 1. And 4 by 2, which is 2. So this gives me negative 3 plus or minus 1 square root of 3, which is really just square root of 3. Okay, over 2. So I get negative 3 plus square root of 2 over 2, and negative 3 minus the square root of 2 over 2. So you, of course, can always double check your answers. So I got negative 3 plus or minus the square root of 2. Oops, I need to do that. All right. So you could also write it as negative 3/2 plus or minus the square root of, oh, sorry, that was supposed to be 3 over 2, which is what I had. All right, letter B said 3x squared minus 2x plus 7 equals 0. So again, I'm going to use the same quadratic formula. So my A is 3, B is negative 2, and C is 7. So it's really important to include that minus sign out in front. Okay. So A equals 3. B equals negative 2. C equals 7. Okay. So when I write this, I have negative B, which is negative 2, plus or minus the square root, B squared, so negative 2 squared minus 4, A C, then all over 2A. Negative b plus or minus the square root, b squared minus 4ac all over 2a. Okay, now I simplify. Negative, negative makes a positive. So I have 2 plus or minus negative 2 squared is 4. 4 times 3 is 12. And 12 times 7 is 84. Okay. 2 times 3 is 6. 2 plus or minus the square root of 4 minus 84 over 6. That gives me 2 plus or minus the square root of negative 80 over 6. Okay? So now I need to simplify what is in my square root, which is negative 80. Okay? When I break down negative 80 is 2 times 40. 40 can break down into 2 times 20. 20 can break down into 2 times 10. 10 can break down into 2 times 5. There's 1, 2, 3, 4 sets of 2s and a 5. So that means I can take 2 2s out, or 4. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 is a perfect square. So 80 can be written as negative 16 times 5. Okay. Okay. It's a negative 80, so I can rewrite it as negative 1 times 16 times 5. Okay. When I do that, I'll rewrite this over here. And then I have negative 1 times 16 times 5 over 6. So I have 2 plus or minus square root of negative 1 is I. Square root of 16 is 4. Plus or minus 4i square root 5 over 6. I have a 2, a 4, and a 6, which can all be simplified by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. 6 divided by 2 is 3. So this is my final answer. I can double check my answer. So 3x squared minus 2x plus 7 gives me 1 plus or minus 2i square root of 5 divided by 3. Now there's about 13 different ways that you can write this answer. That is one way. Okay. 1/3 plus or minus 2i square root of 5 over 3 is another way. Either way, it's up to you. Okay. All right, example 2, choose a solution method. So I'm going to solve the equation 6x squared minus 7x minus 20 equals 0 using 2 different methods. Which do you prefer and why? Realistically, whichever method that you prefer is completely up to you. I personally prefer the quadratic method because it makes my life slightly easier and I don't have to deal with completing the square, which I kind of find annoying. Personal preference. If you want to use completing the square and you like completing the square, please use completing the square. Okay? Doesn't matter. All right, so quadratic formula. Using quadratic formula, a equals 6, b equals negative 7, and c equals negative 20 gives me this answer. Factoring by grouping. Kind of like completing the square. 6x squared minus 7x minus 20. Okay? I can say that negative 15x plus 8 will get me the 7x. 3x times 2x minus 5 plus 4 times 2x minus 5 equals 0. I get the same answer. Notice, same answer. Negative 4/3. Okay. You can find this by trial and error. So, most solution methods give the same result. Factoring may be more efficient, but the quadratic formula always works, regardless of whether the function has real or imaginary roots. Also the reason why I prefer. So they want us to solve the equation 6x squared plus x minus 15 equals 0 using the quadratic formula and another method. Okay. You can use whatever other method that you would like to use. You can use factoring. You can use completing the square. You can just use trial and error, kind of up to you. So I'm going to go ahead and use factor by grouping. So when I factor by grouping, I get the following. 6x squared plus x minus 15 equals 0. And when I factor by grouping, in order to get 15, okay, so in order to get multiples of 15, but add to equal 1, when I'm still multiplying by 6x, I get 6x squared plus 10x minus 9x minus 15 equals 0. So I get 2x times 3x plus 5 minus 3 times 3x plus 5 equals 0. So I get 2x minus 3 and 3x plus 5 equals 0. So I get 2x minus 3 equals 0, or 3x plus 5 equals 0. So I get x equals 3 halves, or x equals negative 5 thirds. Quadratic formula. When I do this, I get x equals negative 1 plus or minus the square root of 1 minus 4 times 6 times negative 15 divided by 2 times 6. This is negative 1 plus or minus the square root of 361 over 12. Okay. The square root of 361 is 19. So when I do this, I get x equals negative 1 plus 19 divided by 12, or negative 1 minus 19 divided by 12. So x equals 3 halves, or negative 5 thirds. So again, either answer works. Quadratic formula always works. You don't have to factor anything out. You don't have to figure out what multiply, none of that. You just have to remember the formula. Okay. Either. Those solutions give you x equals 3 halves and x equals negative 5 thirds. All right, example 3 says identify the number of real number solutions. So how can you determine the number of and types of roots for a quadratic equation? So solution. So if I have 2x squared minus 7x plus 3, I have a vertex at 1.75 and negative 3.125. For y equals 4x squared plus 12x plus 9, I have a vertex at negative 1.50. And for x squared plus 2x plus 8, I have a vertex of negative 1.7. So I can solve each of these using the quadratic formula. So x equals 7 plus or minus square root of 25 over 4, x equals negative 12 plus or minus square root of 0 over 8, and x equals negative 2 plus or minus square root of negative 28 over 2. The radicand is 25. Adding and subtracting the square root of 25 gives 2 different roots. The radicand is 0. Adding and subtracting the square root of 0 gives 1 root. And the radicand is negative 28. Its square root is imaginary. So adding it and subtracting it will give 2 complex roots. So the graph shows 2 distinct x-intercepts, and the quadratic formula shows 2 distinct real number roots. So we look up here. two distinct x-intercepts. The graph shows one distinct x-intercept, and the quadratic formula shows one real number root. So it crosses right here at 0. And this graph shows no x-intercepts, and the quadratic formula shows no distinct complex number roots. Okay. So it does cross the y-axis, but it never crosses the x. So the radicand in the quadratic formula is what determines the nature of the roots. So the discriminant of a quadratic equation is the form ax squared plus bx plus c equals 0, is the value of the radicand b squared minus 4ac. So if b squared minus 4ac is greater than 0, it has two real roots. If b squared minus 4ac equals 0, then it has one real root. If b squared minus 4ac is less than 0, then it has two non-real roots, or two complex roots. All right, so let's try it out. Describe the nature of the solutions for each equation. 16x squared plus 8x plus 1 equals 0. So I want the radicand b squared minus 4ac. So b squared is 8. So 8 squared minus 4 times 16 times 1 equals 64 minus 4 times 16 is 64. So minus 64 equals 0. This means it has one real root. One real solution. Okay, we'll see. 2x squared minus 5x plus 6. So b squared minus 4ac equals negative 5 squared minus 4 times 2 times 6. So this equals 25 minus 4 times 2 times 6 is 48. 25 minus 48 is negative 23. Okay, so this is less than 0, which means it has two complex solutions or two imaginary solutions. So non-real solutions. So they're complex, so they'll have an I in them. Example number 4, interpreting the discriminant. Rachel is about to serve and tosses a tennis ball straight up into the air. The height h of the ball in meters at time t in seconds is given by ht equals negative 5t squared plus 5t plus 2. Will the ball reach a height of 4 meters? So to see if h equals 4 for some value of t, I set the quadratic equation of h equal to 4 and solve. So negative 5t squared plus 5t plus 2 equals 4. Okay, I rewrite the equation in standard form. So negative 5t squared plus 5t minus 2. So I subtracted 4 from both sides. My a value is negative 5, b value is 5, and c equals negative 2. The discriminant, 5 squared minus 4 times negative 5 times negative 2 equals 25 minus 40, or negative 15. Negative 15 is less than 0. So the equation h equals 4 does not have a real root solution. Therefore, the ball does not reach 4 meters. All right, according to the model of Rachel's serve, will the ball reach a height of 3 meters? So again, I'm going to take negative 5t squared plus 5t plus 2 and set it equal to 3. When I put this into standard form, I get 2 minus 3, which is negative 1, equals 0. So a equals negative 5, b equals 5, and c equals negative 1. So I have b squared minus 4ac, which equals 5 squared minus 4 times negative 5 times negative 1 equals 25 Negative 4 times negative 5 times negative 1 is negative 20. So minus 20 equals 5. Since 5 is greater than 0, there are two real solutions, and the ball will reach a height of 3 meters. Okay, and it will reach at height twice, so once going up and once coming down. All right, I can also use the discriminant to find a particular equation. What value or values of b will cause 2x squared plus bx plus 18 equals 0 to have one real solution? So for this equation, a equals 2 and c equals 18. The equations will have a single rational solution when the discriminant is equal to 0. So b squared minus 4ac equals 0. So b squared minus 4 times 2 times 18 equals 0. B squared minus 144 equals 0. So b is plus or minus 12. So there are two possible solutions, 2x squared plus 12x plus 18 equals 0, and 2x squared minus 12x plus 18 equals 0. All right, so let's try it. Determine the value or values of b that ensure 5x squared plus bx plus 5 equals 0 has two non-real solutions. So I know that a equals 5 and c equals 5. So when I set this up, b squared minus 4ac equals 0. But I want non-real solutions. Two of them, in fact. Okay. So I want this when this is less than 0. So b squared minus 4 times 5 times 5 is less than 0. B squared 4 times 5 times 5 is 100. So minus 100. 0, I add 100 to both sides. So b squared is less than 100. Square root of b squared less than the square root of 100. Well, square root of 110 is 10 minus 10. That means negative 10 is less than b, which is less than 10. Will give me two non-real solutions. Okay. And again, I used this inequality because I was looking for two non-real solutions. If I was looking for one real solution, I would have said equal to. If I were looking for two real solutions, I would have done greater than. All right, so the concept summary, the key features of the quadratic formula, x equals negative b plus or minus the square root b squared minus 4ac all over 2a. This formula is used to solve any quadratic equation, ax squared plus bx plus c equals 0, where a does not equal 0. Okay, so using the discriminant, I can predict the number and types of solutions using the discriminant b squared minus 4ac. So the discriminant is what is underneath the radical, the radicand. So if it's greater than 0, it has two solutions. It crosses the x-axis twice. If it crosses once or touches once, it has one real solution. And if it never touches the x-axis, it has no real solutions, two non-real solutions. So it involves imaginary numbers. So greater than, equal to, less than. Greater than to real, equal to 1, less than to non-real. And that is the end of Unit 2, Lesson 6.